Hello, my friends. Are you ready for the most essential step of this implementation, which is at the heart of sentiment analysis? That is creating the bag of words model, which we're ready to do now because all our reviews are properly cleaned. So we're going to get them into the bag of words model to create, this sparse matrix, which will contain in the rows, the different reviews, the same reviews as the ones in our corpus, and in the columns, all the different words taken from all the different reviews, all of them. And each cell will either get a 0 or a 1. It will get a 0 if the word of the column is not in the review of the row, and it will get a 1 if the word of the column is indeed part of the words in the review of the row. All right, so that's what the sparse matrix is about, and the process of creating all these columns corresponding to each of the words taken from all the reviews is called tokenization. So that's exactly what we'll do in this new cell. But first, let me actually show you what we created. I just want to show you the corpus. So actually right here, we're going to create a new code cell, and I'm just going to do a print of the corpus so that I can show you indeed what we created. So let's press play here, and this will show the corpus. All right, so this is the first review after the cleaning, after all this cleaning process in different steps. Remember, I can actually show you the original review here. The original review was wow with, capital letters, some punctuations here with the 3 little dots, and then loved this place. And after the cleaning process, it became wow, love, place. Indeed, we removed all the stop words such as, this, that's an article that doesn't give any hint on whether the review is positive or negative. However, of course, we kept loved because loved means, of course, that the review is positive. However, we transformed loved into love. That's the process of stemming, so we can simplify all the words by their root. And then, of course, we kept place because that's, of course, not a stop word. All right. Then let's have a look at the second one. Crust is not good. All right, so let's try to guess actually how it was transformed. So crust was just transformed into crust with a lowercase c. Then is was probably removed, right? Because it doesn't give any hint on whether the review is positive or negative. Not was definitely kept because that's a negative statement. And good was, of course, kept, okay? So after the transformation, after all the cleaning, this review must become crust with a lowercase c, not good. Let's check that it is the case. And crust, oh, okay, so actually they removed the not, which is a bit strange actually, because, not clearly indicates a negative thing, a negative review. We clearly have a difference between crust is good and crust is not good. So I think we need to do some extra work here in order to not include the not word from the stop word. And I'm going to show you how you can do this. It's very easy. So we're going to work again on this code. I'm actually going to take this here, stop words, all the English stop words. I'm going to cut that. Then right here in a new line of code, I'm going to paste that. Then I'm going to create actually a new variable, which I'm going to call all underscore stop words, right? And which will be equal to exactly this. But then what I'm going to do just below is to take this again, which was now created as, this whole ensemble of all the stop words, but we don't want to include not in this stop word because that's clearly a negative term, indicating therefore a negative review. So I'm going to paste that here, and I'm just going to add here a dot, remove, and in the parentheses, I'm simply going to include in quotes not. All right, so that will not include the not word from the stop words, and therefore here, instead of taking the set of the original ensemble of stop words, we're now going to take the original ensemble of stop words, excluding this time the not word. Let's see if it works. I'm kind of improvising things here, but it might work. So we actually have to restart the runtime. So let's do this. Restart runtime. Yes, we still have our data set, all good. And now let's see if this works. So we're going to re-execute the cells. I cannot do a run all here because the implementation is not over, but let's import the libraries first. Now the data set, and now let's clean the text. I hope this will work. Let's play. All right, this seems to be good. Good. Now let's remove this output. This was the previous output, right? And now let's print the corpus and let's hope that the second review is now no longer, crust good, but indeed crust not good, okay? So let's press play and perfect. Okay, good. I'm relieved. This was really bad to remove the not because it's clearly a negative term indicating a negative review. All right, so much better now. And actually, same for the next one, not tasty, texture nasty. That definitely means a negative review. Let's actually check that, right? Yes, not tasty and whatever, 0, negative review. And same for this one. All right, so good. We have actually a much better model now. So we can continue and we can mostly create the bag of words model. All right, so let's do this. Let's actually scroll down a bit and there we go. New code cell. And now let's proceed with this tokenization to create this sparse matrix containing all the reviews in different rows and all the words from all the reviews in the different columns, where the cells will get a 1 if the word is in the review and a 0 otherwise. All right, so we're going to do this with actually Scikit-learn. The tokenization process will be done thanks to a class from Scikit-learn, more specifically from a module of Scikit-learn called feature extraction, and that class is called count vectorizer. All right, so let's do this. Let's start from Scikit-learn. You know this library very well, sklearn, from which we're going to call that feature, there we go, extraction module, from which actually, it's not over, we're going to get access to the submodule called text. Text, from which we're going to import that count vectorizer class. Perfect. I really love Google Colab when it assists me this well. Okay, so we have the class. Now you know what is the next natural step. It is to create an instance of this class. And we're going to call that CV as count vectorizer, which will be created as, an instance of this count vectorizer class. Perfect. Which has to take as input only one important parameter. Can you actually guess what it is? Well, it is actually the maximum size of the sparse matrix. The maximum number of columns, therefore the maximum number of words you want to include in the columns of the sparse matrix. And why is this important? That's because, in our corpus of reviews now, with all the simplifications, well, we actually have still some words that are not relevant or, not helpful to predict if a review is positive or negative, even if they were not part of the stop words. And these include, for example, texture. Texture doesn't really help to predict if a review is positive or negative. Or, bank, or holiday, or Rick, and even Steve. Steve doesn't help at all. So we still have these words which, even if they're not part of the stop words, don't help at all to predict if a review is positive or negative. And the way to get rid of them is by, entering this parameter that we're about to enter. The way to get rid of them is just to take actually the most frequent words, the words that appear most frequently in the reviews, because probably here Steve only appears once. So if we only take the most frequent words, we won't include Steve in this sparse matrix, in the tokenization process. So that's the trick. And so now we need to just choose a maximum size of the sparse matrix. However, we can't really know now how many words there are in total, before we take the most frequent ones. So what we'll do, in fact, is we will leave this for now. We won't enter this parameter now. We will run this cell once we create the sparse matrix, which is actually going to be the matrix of features when training our naive Bayes model on the training set. It's going to be the matrix of features, and therefore we will do a print in order to know the total number of columns. And we will get therefore the total number of words, and then we can reduce that total number of words to a lower number of the most frequent words in the sparse matrix so that we can simplify even more the bag of words model. Okay, so that's what we'll do. Therefore, so far, let's not enter anything. Let's just continue to create that bag of words model. All right, and actually, speaking of the matrix of features, that's exactly our next step here. We are ready, thanks to this count vectorizer class, to create the matrix of features, which is indeed that sparse matrix. So we're going to call it X as usual, as every of our previous matrices of features. So X equals, and now according to you, what is the next step here? Well, you guess that we're going to create this sparse matrix thanks to our CV object. So there we go, I'm calling CV first, from which I'm going to call now a method which you know very well, which we already called many times, and that method is the fit transform method. All right, the fit transform method, which will indeed fit, well, you know, the input of this fit transform method, which will be, you know, I'll tell you now, the corpus. It will fit the corpus to X. And what does it mean? It means exactly that it will take all the words from all the reviews in the corpus, and then using this transform part of the method, it will put all these words in different columns. So you see, that's very simple. The fit method will just take all the words, and the transform method will put all these words into the columns. That's it. Nothing more. Okay? So, of course, inside this fit transform method, we have to input our corpus of reviews, of very cleaned reviews. And then we just need to add here a to array, because actually, you know, remember that the matrix of features must be a 2D array. It has to be a 2D array because then, you know, we will train the naive Bayes model on the training set. And this expects, of course, an array as the format of its input, you know, the matrix of features. So, you know, X will be an array here, then it will be splitted into the training set and test set, you know, with X train, Y train, X test, and Y test. And then there we go, we'll have the right array format to train the naive Bayes model on the training set composed of X train and Y train. So to array, let's not forget the parenthesis. And now there we go, we're almost done. Our final step here is to create the dependent variable vector Y. And actually, I will let you do this now because you know exactly how to do it, right? We simply need to take that second column here because that's exactly the dependent variable vector, and we don't have anything to do here because it's already ready with the binary outcome 0 or 1. And so, well, the way to get this is actually very simple. And I'm actually thinking right now of an even simpler way, which is to go to our data preprocessing template, then take this line of code, because you know, I'm very lazy. And so I'm copying this and pasting it right, you know, deleting this and right here. And that's exactly our dependent variable, right? It is just taking the last column of our data set, which is the same as the second column, right? You can either put a -1 here or the index 1, but we want to make this a code template if we can. So let's just keep that. Okay. Wow. So good. We're done with actually the bag of words model. So now, as we said, we're going to run this to figure out the number of columns in the matrix X, meaning the total number of words in that sparse matrix. So let's play this cell in order to first create X and Y, and then we'll do the necessary to indeed get that total number of columns in X. And that's exactly what we're ready to do now. You saw that this cell executed properly. And now the trick to get that number of columns in X, or you know, that number of words resulting from the tokenization, is just to call the len function here, which is going to take as input this matrix of features X, and then only the first row, right? Remember that the first index here in the pair of square brackets corresponds to the index of the row. All right, so this will give us exactly the number of elements basically in the first row, therefore the number of columns of X. So let's see, let's press play, and we're gonna get now that indeed, wow, okay, there are 1,566 words resulting from the tokenization. Basically, we have 1,566 words that were taken from all the reviews, and for each of the reviews we have either a 1 in the columns corresponding to the words that are in the review, and a 0 to all the other columns corresponding to the words that are not in the review. All right, so basically we have 1,566 words, and we can simplify this even more by, for example, taking the 1,500 most frequent words so that we can, you know, get rid of words such as Rick, Steve, and maybe, you know, holiday, or let's say, you know, faux. I don't know what that means. Rubber, you know, this probably appears only once, and, you know, words like that. Words that don't help at all predict if the review is positive or negative. Okay, so that's the idea. So let's just take, you know, the 1,500 most frequent words, and therefore to do this, we just need to enter max underscore features parameters. There we go. And in order to get only the 1,500 most frequent words, we just need to enter here 1,500. 1,500. And feel free to try with other values, like for example, the 1,000 most frequent words, but be careful not to remove too many words, okay? All right, so good. Therefore, now we're gonna, rerun that cell. So let's do this. Let's press play. Okay, good. And now if we rerun that cell, we should get 1,500 here. Perfect. So now we have a nice bag of words model with only relevant words, that appear at least a certain amount of times, and without all the non-relevant words that appear once, like Rick, Steve, or that weird faux word we saw in one of the reviews. Okay? Good. And so now, well, we basically did the most difficult part. We created the bag of words model. And so now I actually have an exercise for you, which you're going to do by yourself first before we do it together. It is, of course, to do all the rest of the different steps here. And you know how to do them because you basically have everything. You have the matrix of features and the dependent variable vector y, which you can therefore split into a training set and test set, composed respectively of x-train and y-train and x-test and y-test. Then you're going to use the training set composed of x-train and y-train to train the naive Bayes model on the training set. Then you're going to predict the test set results using the test set, containing therefore reviews and their outcomes on which the model wasn't trained. And finally, you're going to make the confusion matrix and compute the accuracy. Of course, you're going to do this using your machine learning toolkit containing all the code templates we built so far. So you totally have the right to do that. And I actually hope that you're going to do this because I want you to be as most efficient as possible. And therefore, that's exactly what we will do in the next and final tutorial of this section. I will show you how to juggle with our diverse toolkits, and especially the classification toolkit, to, in a flashlight, split the dataset into the training set and test set, then train the naive Bayes model on the training set, then predict the test set results and making the confusion matrix. I will show you that I will do this with only copy-paste, nothing else. We won't type any code now. We have everything in our diverse toolkits. But please make it first, please do it on your own first, and we will implement the solution together in the next tutorial. Until then, enjoy machine learning.